All right, welcome to this week's lesson. We're going to talk about exception handling. My name is Professor Chepkowski, and let's go ahead and dive right into it. So, why do we want to understand exceptions? Unhandled errors can cause software to crash or misbehave. If you're lucky, the result just irritates a user, but if you're unlucky, your business can end up losing money. Imagine you have a pay system, and every time somebody enters the number zero into their credit card information, it crashes. That's not very helpful, and it could cost your business a lot of money. So you want to have error handling that raises up and tells somebody what's going on so they can fix it. So in Python, we have this concept of exceptions. Even though you might never ever thought of it, Python uses exceptions everywhere. In generators, for example, it raises an exception to signal the end of a given list using the stop iteration. So you can go ahead and create a generator just by using a tuple and n in for n in range, and just keep calling next on that generator. And when you reach the end, you'll see this basically this stop iterator being raised. That doesn't mean every time you use this, the person is going to see the code. Python knows how to handle that gracefully and will just continue on with your code without actually bubbling up that exception. So what are exceptions? Exceptions are just an error that occurs within your program, and it interrupts the normal program flow. It's represented by a Python object, and there's three general types of exceptions. You have syntax errors, runtime errors, and logical errors. A syntax error is a typo, essentially, error within the code syntax. Maybe you don't have something tabbed in enough. Maybe you've, flipped a letter in something. Um, Runtime errors are errors that occur during the program's execution. Maybe somehow you have a program that does division and you end up dividing by zero or something like that. Or maybe you run out of memory. I don't know. You can also have logical errors, which could be an error in your programming logic, which also could be that divide zero by zero error that occurs, or just something that just doesn't, maybe a case you didn't handle, like you never expected somebody to enter this data type in and the thing explodes. So uh, the catching these exceptions helps you write better software. So let's take a look at this one, the ever classic divide by zero. So we're going to have a function called divide. We're going to divide this value. So if we pass in 10 divided by zero, we're going to raise the exception to zero division error and say, and we can then go ahead and do something within our try except block. Uh, when we handle exceptions, like we saw before, we're going to use a try except block or try except finally, and it's going to encloses the code that might be raised during the exception. The except block handles that specific exception. So you can either list them out by individual types, like divide by zero, or you can use the generic exception one as well. You can handle multiple different exception types to go different processes that you need to do to make sure that these things don't raise. And you can use a tuple to handle multiple exceptions in one exception block. So let's look at some examples. In this one, we're going to have some user inputs. So we're going to enter a number and then another number for X and Y and do the division. So the first exception that we have is, let's say someone enters in the letter A for X, and you can get a value error. So it basically says that this isn't a number, and you print out an informative message. And then we have our exception that does division by zero error, and it just says that we have division by zero again. So we can go ahead and handle these exceptions in different ways. So we can do we have a function divide in our try except, and here we're capturing both division errors and type errors, and in just a generic, this something bad has happened. And we can also capture our value error here with the except, so we can have them sort of spread out. The else and finally blocks. Um, so in our try except, we have these things called else blocks, and these will always occur if no exception happens. That means everything's good. We're going to go ahead and do this. Finally, always executes regardless of whether the exception occurs or not. A lot of times these are used for some cleanup action like closing a file or database connection. So let's go ahead and look at a full example. Here we're going to go ahead and open our data. So we say file equals open, path to our data.txt. We set to R as read. We're going to read our data in. Now, if an exception is raised, like file not found, we're going to print out a message. Else, we're going to print our data out because that means it succeeded, so we can move on. And finally, it does that file close to make sure our resources are closed up. Even though Python has a robust library of standard exceptions, there are cases where you might want to build or create your custom exception or raise your own. Raise one of them, even if Python doesn't raise that exception for you. So to raise an exception, we use the raise keyword to manually raise an exception. We can create custom exceptions for a specific error condition. Custom exception has to inherit from the exception class, and you want to provide an informative message to that error. So let's go ahead and take a look at one. We're going to first define our invalid age error, and we're going to inherit from exception. Because we're just going to accept everything to be standard, we can just put a pass in so we don't have to write any code. Now, when we want to go ahead and check our age, we can say if age is less than 0, we can say invalid age error, and then age cannot be negative. In ArcPy, there are custom exceptions. So errors occur in ArcPy script executions. They interrupt the normal flow of what you're trying to do, and they can be handled in a try except block. There's common exception types. We have our execute error, data not found error, license error, and geoprocessor error. These are raised for different reasons. Execute error indicates that a geoprocessing tool has failed in the ArcPy environment. Data not found is pretty much what it means. It just means that the data set is missing. The license error occurs when a required license is unavailable. And in practice, the geoprocessor, because it's the base class for a geoprocessing exception, you really shouldn't encounter that much. But if you do, sometimes it's always a good practice just to handle it. Knowing what these exceptions are saying, we'll get back to, is very important. So you need to know how to handle them properly. So we can handle these ArcPy errors in the try except block, and we can enclose the code that might raise an exception and use the except to handle the specific error. So let's say we get an execute error copying our data set. Maybe it already exists, the output. We can have an accept arcpy.execute error and then print out the arcpy message. And we do the to get the last message or the most recent message. So we do arcpy.get to get that detailed information, as you saw in the previous slide. We can do arcpy.get messages function and retrieves the detailed error messages. Using the arcpy messages to, we get the most recent message. And it's a good practice to look at that last message because it's usually the most informative one that's occurred within the process. So the best practices, just to sum up, we have for exception handling, we have specific exceptions, and these handle specific problems and provide informative messages. Then we have generic exceptions, like the general exception class that's used in the generic try except blocks as a last resort. You should always log your errors and provide user-friendly messages. And you shouldn't just put your code in a whole bunch of try except blocks. You should do testing. And by following these guidelines, you'll be able to create more robust and reliable ArcPy scripts. So that's it for this week's lesson. If you have any questions, feel free to reach out, and I will talk to you later.